The technical detail of Cimatron version 15 now. We are looking into some of the new tools, such as conformal cooling. So to follow on from some of the highlights as such, the new tools are very much in line with the other 3D systems software solutions as such. So this conformal cooling is something that was brought out in version 14, but has been vastly improved into version 15 with improved user experience, making it much easier to design and develop your cooling channels as such. Much more automation with regards to how these cooling channels are being developed. It's much more easier to define the area which you want to cool, with advanced analysis tools as well for printability of channels. So this is obviously tying into the 3D printing of metal inserts with regards to the overhang limits of metal printing. Distance from walls is also a new analysis type where we are able to more effectively design the cooling channels for those kind of tight areas close to the walls, maximizing the efficiency of the cooling, which ultimately leads to getting it right first time. So a quick demonstration of the cooling tools for version 15. So we are looking at an insert here. We're looking at the cooling design tool with regards to creating a line and corner radius of the part here. We're doing a quick analysis for the overhang limits of this cooling channel. We can see it's highlighting the areas that are above the overhang limit set at 45 degrees. So this gives us a very good feedback for the 3D printability of our insert here. Now we are looking at kind of procedurally generating the cooling channel, and you can see how it's been created along the spline arc here. We're going to do a quick check to see if there's anything wrong with this design, and we can obviously see there is a slot into the part here, which is obviously being highlighted as it's being going through the outside of the geometry. And we're just going to go back and see how easily we can edit this geometry to be suitable. So moving back to the control tool here, we can see we can actually just pull the geometry down into a more suitable position here. This is again coming back to how we can use our analysis tools with our creation tools to more effectively create the geometry. Again, swapping back to the analysis, and you can see how quickly the analysis tools are working with the design tools. You can see that we've got quite close to a nice geometry, but there is still some areas which are too close to the wall. So we're just going to move it ever so slightly more out of the way. Come back, do another little check. So you can see how quickly the design iterations of this is going to be created as such. So this is, of course, a manual generation of this geometry. So we're now going to look at how we can more easily create an automatic conformal cooling design. So with the new auto conformal cooling tool, so we can select faces that allow us that we want to create the conformal cooling for. We can set our our existing cooling channels. So we can say we want to enter these existing cooling channels. We can set our in and out positions, our entrance and exit positions. And we can auto-generate a spline curve which maximizes the use of the tool as such. So this is getting to a very good point of use of this insert as such. Again, coming back to the conformal cooling design tool, we can now select this spline geometry for creating of the channel. You can see that we've got all of the control over position still with this complex spline curve being created. We are able to check the curvature of this spline tool. We can check the closeness to the wall. So because we have already defined a 4 mm gap from the wall, we should be well within the tolerance of what we've set within the analysis tool. This is all about kind of maximizing the efficiency of our tool in the end as such, and we want to create this geometry with the maximum efficiency. So you can see how quickly this analysis tool has been used as such, even with a complex spline geometry as shown. You can see that we're still a little bit close in certain areas, but well within what we can manage as such. And again, we can do an analysis of how close we are to the wall. Seeing now that we are nicely generated here. And once we press OK, the geometry is finalized and we can create it. Again, how quickly this is possible is testament to how powerful the engine is being used here. Brilliant. So moving on from here, we are looking at how our cooling tools have now been improved with regards to cooling analysis as such. So now we have a new cooling distance map, which is now a mini mold cooling analysis using some V-ray detection as such to simulate how the cooling is going to be affected against our active faces and the cooling parts. This can be used with our conformal cooling, but also our traditional cooling tools. So it makes it much quicker to check the cooling efficiency of our part. So just coming back to Cimatron, we are now going to do a quick cooling distance analysis on our geometry. So we're going to select our part and select the geometry of the cooling. And we're going to begin our analysis. Again, it's very, very quick and very easy to check this now as such and get a real good feel of how our cooling is affecting our part and seeing how effective it can be. And of course, for conformal cooling, it's maximizing that efficiency of cooling as such. So we can see that we have highly interacted with the surfaces, getting maximum cooling for the geometry. Now moving to a more traditional cooling design as such, we're going to do the exact same cooling analysis. So we can see we've used more traditional cooling channel design and more traditional parting design. And again, that cooling distance map is applicable here. Quickly analyzing the geometry for an effectability of this. Again, this can be published out to a PDF if need be to show to a line manager or to a design manager. So you can see we might need some more areas of cooling on the top surface there. So moving on, we have got some improvements to the cooling labeling, which certain people have asked for as such, for labeling up cooling entrance and exit holes within the part. So this is quite a nice set of tools. So just moving ahead and playing here, we're going to begin a cooling labeling. So we can see how we can change the font, change the text position, change the number used for the cooling labeling. We can add prefixes to it, say it's an in or out hole as such. We can move the position of it. Very quick and easy to add this into a design as such, and obviously can be used with the NC or with the drafting to make it very effective for displaying to another user. So this again is just we can do this on the other side as well. Apply the naming convention on the other side as well. So very simple and very easy to customize, but also to implement this labeling technique. Okay, so moving on to the NC highlights. This is looking at some of the new tools we have in the NC, which is a big part of version 15. So some of the new highlights is the mill turn functionality, the plate machining automation enhancements, the enhancements to the 5-axis machining in terms of multi-axis roughing, finish with the geodesic technology, the guided multi-axis cleanup, and the 5-axis deburring. We have reduced times with enhanced AFC, with the circle segment cutters and on-machine probing. So this is some of the new functionality we have, as well as 3D cutter compensation, which is very, very powerful for increased tool cutting. So to look at the mill turn application, which is something very new, we have a target to complete the entire job in one machine operation. It's designed for mill turning machines and milling machines with turning capabilities. It's a one spindle system as such at this moment. It's an ATC type machines, but it's not meant for multi-turret machines or Swiss machines. We are using the GibbsCam engine in the background to process the mill operation, but it's fully integrated with the Cimatron tool set as such for design of stock and tool parts as such. All basic turning technologies are supported. So this is something quite large for the Cimatron with this new technology as such. We have thoroughly tested the capabilities of this, and it's really well designed with the GibbsCam in the background as such. So we're supporting more machines now with this as such. So we support mill turn and turning machines. It means we're going to be faster machining and better surface quality. It's going to be combining turning with advanced 5-axis milling. So that combination of the two is possible now within the Cimatron software. It's still using the GPP2 post, which is very nice for our existing customers using the GPP2. Obviously, the post already created will need to be amended for this turning capability. This does not mean that we are kind of overtaking GibbsCam or anything of the sort as such, as we're not supporting MTM or Swiss type machines, and we're not supporting multi-turrets as such. So, as I said, we are using the GibbsCam engine in the background. So in the Cimatron environment, we have got the machine, the setup, the stock, and the geometry. When we define this, we then access the GibbsCam engine to create our tool paths. So the tool definition dialog is part of the GibbsCam, the procedure parameter dialog is part of the GibbsCam, and the tool path calculation is part of GibbsCam, but used in the background. The display navigation, the stock update, post and report and simulation is still within Cimatron and completely applicable with any of the turning operations, which means that our stock is going to be updated, which means that we can interact with 5-axis procedures whilst doing a turning operation. So we benefit from both the Cimatron environment for geometry, simulation and post, but we use the powerful GibbsCam engine for robust mature turning as such. So looking into the workflow, we obviously want to define our turner cutters first. So again, we're pulling the GibbsCam tools for this as such for easy definition of our turning cutters. So key dimensions are used, ISO standards are used with predefined tool shapes, user-defined for tools and holders. So we still have that ability to define our own holders. Moving on to our designed contour for creation as such. So this is looking at how we can revolve the shape to create the desired profile of the geometry as such. So there's some really powerful design tools here using kind of 3D silhouettes, spun silhouettes for the turning body. Cimatron CAD is being used to its utmost here with regards to making this very quick and efficient, with many other options for creating this geometry. Now looking at the turning strategy, again pulling from the GibbsCam, we have roughing strategies, we can turn, pattern shift, plunge, etc. We have the volute turn for high-speed roughing using round inserts. We have contour creation for finishing operations. We have drill, groove, and threading tools as well. We can look at how the roughing procedures or finishing procedures are being created in terms of outside diameter, inside diameter, front face, back face. We have full control over the technology with regards to cutting direction, tool orientation, entry and exit positions. It's a one-stop model, so this is something that is different to other softwares in the fact that we have the full capability of creating stock, which is updated throughout the process, even with other applications such as 5-axis machining. So we have a stock model which is updated throughout the entire process for both turning and milling procedures. Very, very powerful, very interesting. We have two types of new stock models in terms of we have a bounded cylinder or we have a revolved spun silhouette, which allows us to, of course, get to the geometry much quicker and then take it to the next step of milling it to the desired shape. And finally, we are very confident in this. So again, throughout this process, it is a known system within GibbsCAM as such. It's not something that we've created, but we've implemented something which has already had much development throughout the years as such. So we have the ability to actually simulate the machine as such. So we can simulate the turning procedure on top of the milling procedures, drilling procedures, and see that throughout the display and navigation, and also see that in the post and report. So moving on to a quick demonstration here. We're just looking at some of the procedures that we can do here. So we're looking at creating rough spirals on top of turned roughing procedures. So looking at the stock of the part, we can sift through and see how the stock is updated throughout the procedures here. And we can look into the turning cutters to see how the geometry is created for a turning cutter. So you can see how we're still using the cutter library here. But if we wanted to add a new cutter, this is when the GibbsCAM engine is opened up. So you can see how we've got new turning tools. So 80 degree, 75 degree, we've got 3D forms, round tools. This is all under ISO standard as well. We can change the tool holder, design a new tool holder if need be. So we've just created a new tool. Obviously you can rotate around it like similar tools, see it in the environment. So we've now looked at creating a new contour for the part here. So we can see how the silhouette has been generated for the profile of the part here. We can see the contour creation for our desired direction of cut. So we've selected the contour. We can see a start and end point, which will be the start of the tool moving to the end position. So it's giving us a direction of tool path. We're then going to look at selecting our tool here. So similar dialogue to what we've seen before. Then moving on to our toolpath creation. So we now access again into the GibbsCAM engine for creating our process here. So this is obviously talking about how our holder can be directed into the part here. So what's our starting position? Very simple. And we can obviously calculate now. We can see the calculation here. So we're obviously doing a finishing procedure. Really quick to navigate through this, see how the geometry is being cut. It's all very similar to what we've seen before. So finally, we can move to a machine simulation. So this is again looking at we can implement the machine simulation with these turning procedures. So again, this is a mill turn operation, so we can see the turning operation in situ. See how we can get a really nice finish on our part. Do some boring operations. All really easy to set up and implement as such. Again, now doing a finish operation. Now moving on to the 5-axis milling here, we can see how the implementation of the two has allowed us to create this complex shape. drilling operations. Again, 5-axis drilling operations applicable here. So hopefully that gives you an insight into the turning operation as such, and how that setup is created, and how the implementation of the Gibbs cam is really, really powerful for mill turn operations as such. So moving on to some additional NC highlights, we're going to look into plate machining. So this is some development with the plate machining seat as such. So we now have the ability to auto-detect the direction of a 5-axis mill. So this is allowing us to create better operations, cleaner cuts as such. Its detection of slot and corners is also implemented as such. So we can now detect that geometry even better. So we can also look into corner plunging. So in the Pocket Manager, it detects corners, vertical or slanted at an angle, allows us to generate plunging motions that are parallel to the cylinder, and it has that gouge and collision free detection as such. So just having a little video of this as such. So again, we're just moving down, and we can see this motion is really, really good for a plate machining procedure as such. Get that nice geometry there. So again, we can do a similar operation for a slotting procedure. So the Pocket Manager detects slots as well. It can say it has a likelihood situation as such, so it can generate a 0 to 100% possibility of it being a slot, which is quite nice because it allows you to see where it thinks the slots will be. It allows us to generate a central center line for easy access into the part. Machining on center lines is user control and user contours as well. The slotting and ramping or trihedral design type as such. And again, another video just to see here. You can see how the slotting process works. We've had some advancements to the automated drill. So the automated drill has now got a better grouping name convention as such, where it is identifying the geometry and giving it a name with that geometry as such. So it gives you some insight into what procedure to apply to those holes as such. This is again dependent on the design iterations as such for procedurally generating the holes. The sequence numbering has been improved as well, so we can now move around sequences, edit them more easily. We can also manually assign groups on or geometric changes. Moving on to the enhancements within the 5-axis. So the 5-axis has seen a lot of new iterations here, new advancements. One of the new advancements is the automated multi-axis roughing. So this is a new element of the 5-axis tool for analyzing and suggesting a best direction for roughing for maximum material removal. It considers the part, the stock, and the tool holder in these directions. It has an interactive or an automated optimization. So an interactive one will give you 3 suggestions for best direction with a 0 to 100% indication of the best direction, and with that it shows you which one is likely to be the best orientation. And with the automatic tool, we can actually use this as an automatic generation with that percentage chooser, and you can also apply this in a template as such. So in the below images, you can see the different directions that the toolpath is being used in, which have all automatically been detected by Cimatron. Another enhancement to the 5-axis is advanced finishing with the geodesic technology. So this is a new procedure which can be used in 3-axis up to 5-axis toolpaths, including undercutting. So we can see how to best approach the part for undercuts. It has many applications, including true 3D step over and morph procedures as such. It has single or multi-guide curves, so we can select multiple guide curves for the geometry to be created off of. It's a really effective tool, looks really good, gets a really nice surface finish with it as such. It has different working modes as such with regards to contact mode, or supports all types of, it has contact modes for supporting all types of cutters, or center mode for supporting ball and lollipop cutters. It also allows the collision-free pattern generation with these tools for sharp inner corners. So just looking at some examples here, we can see the geometry is being followed with the 3D step over. So quite highly complex. Moving on to the 5-axis undercut tool. So we can see the undercut on the part here. And see the tool and how it focuses in on these areas as such. So with a, you can see the directional undercut here. You can see how the operation is following around the geometry here. So again, really effective for getting into those hard to reach areas. And finally, we can look at some 3-axis with T-slot cutter for undercuts. So we can see the geometry created here. And we can see the toolpath being created. Really good for surface finish again. Okay. So with this automatic detection of optimal direction, we have some also uses within the guided cleanup. So within the cleanup operations, we can also use the analysis for best direction. So this is now analyzing and suggesting best cleanup direction, which again considers the part, the tool holder, with options for split segments with overlap, options for the snap to existing directions, so creating your own UCS, or it can create its own UCS with the desired, the best direction in mind. So looking at this video here, you can see how the direction is being selected. Segment is now moving down with the best direction. So the different cleanup, we can auto direction here. Auto direction is now being calculated. And you can see how the direction is now automated for best cleanup. Okay. Moving on to automated 5-axis deburring. So again, toolpaths for 3, 4, and 5-axis with auto detection of sharp edges. Runs around the outer shape of the edge of the part as well. It has automatic collision avoidance, so if there's any collisions that the tool can see, it will avoid those, and automated linking to lead in and lead out for ball and lollipop cutters. So really, really nice for that cleanup of a part as such. So overall, there's been some enhancements to the AFC, the automatic feed control, including on the next rough and as re-rough. with better stock recognition, with reduced drastic load changes, longer tool life, and faster machining, as you can see below. We have some new tools, circular segment cutters. So this was brought out in version 14, but we've had some massive advancements with regards to how these tools are used within the Cimatron software and how the calculations with these tools are being generated. So the different types of cutters are the barrel, lens, oval, and 3 radii tools. So a lot of people tend to not use these tools yet, but they are very, very powerful and give you much more effectiveness of your tool pass and your cutting procedures as such. So as well as we've got finish by limited angle now, which allows us to take into consideration these tools and use them more effectively with a min-max horizontal angle and vertical angle. So this allows us to more effectively have connections with our tool as well. So again, this is mainly used for the circular cutter tools for more effective removal and also better surface quality. So some examples for the 3 radii cutter in a 3-axis procedure with a small mold part. So we can see some ball cutter versus a 3 radii cutter. So you can see the step over is between 0.89 and 0.49. So there's no loss in time, but there is a less of a better finish with the 3 radii cutter. The 5-axis operations also are better suited for a 3 radii cutter. So this is now looking at a bigger step over with a small advantage to the time, but it just means that we get a better process out of this. Now, the major advancement is on really big molds. You can see here that we have got a much similar step over count, but we can see the machining time is 13 hours better with a 3 radii cutter. The calculation time is much higher, but overall we are still saving time on the machine, which is where we want to be saving time, where we're going to be saving money as such. So moving on, we've got reduced machining time on machine inspection. So this is a new tool with the on-machine inspection in regards to we can now tell the machine to create a collection of points, and we can save those points that can then be read back into Cimatron. So this is kind of becoming more of an inspection report system as such in a basic sense. And I really like the look of this because it really gives some feedback to the Cimatron users in the NC side as such. So let's just have a look here. So this is just a basic setup as such for the on-machine inspection. We can set the points for our inspection, the directional analysis here as well. We can see the path that the tool is going to be moving in. We can see the navigation of this detection. And again, this can be read back into Cimatron once the data has been captured on machine. So yeah. So looking at the measurement report, we can see so inspection report here. We can see the readout from this with distances and deviations. We can obviously set tolerances with this as well. Highlight min-max problem areas. Brilliant. Okay. We have some new finish functions for 3D cutter compensation. So we use for cases with high accuracy as required. allows machining of the same program by adjusting on the controller. So this is for on-machine corrections with 3D compensation values. Without the need of recalculating the toolpath, we can generate these compensations. It can be used for 3-axis G-code output. It's a normal vector calculation and is mainly used for 3D surfacing at touchpoint. Shank and holder control is now different than it was in the previous version. We've now got a much nicer user interface for this. It's allowing us to more easily control what is being used in our shank and holder calculations, making it quicker to process a toolpath with that compensation in mind. It's similar to what you might see within the 5-axis operations, but now can be used with 3-axis operations. It has better safety for different parts as such, better accuracy for machining for good surface quality, and it has a good minimal clear length as well for calculating of the best cut as such. And again, we can generate this with collisions in mind, so we have that safety assurance within the part. Something new is the utility procedure. So this is a new way to send messages via the post-processor. So this is a bit unusual. It can be used for different procedures that aren't common within the operation technology as such. So this is for if you've got maybe a robot arm involved within your process, so you can control that via the controller as well. So we can obviously do things like machine-dependent codes and other types of turning operation stuff. It appears in the process manager under the message tool. So we've also got an advancement to the coolant types. So we've added more coolant types to the defining here. So we can define more cooling with additional user control. We can add multi-coolants. So if you've got flood and mist or anything else as such, you can obviously control that. Okay, so that is version 15 in its mostly entirety. There are some things that are also advanced in the background. So we can obviously give you the documentation for this latest version 15 to help you if you have any other kind of queries about what's been changed as such. But hopefully that gives you an insight into the major updates, major highlights of version 15.